We'll share it to the top and share it to the bottom. We haven't seen one like that before, but it works the same way as multiply. You just share the power to everything. If I had numbers in the front, they'd get the two also. Everything in this problem, every single piece, every single part of every piece gets that 2. Okay, so I'm going to have x to the 4th. Wait, let me write it. You guys can write x to the 4th if you want. I want to make sure everyone sees explicitly. So x squared over y to the 4th squared, right? So 2 times 2 gives me 4th, and 4 times 2 gives me the 8th. Okay. Because again, I multiplied in between the numbers. So this is Kelly's recommended way. This is her approach. And remember, I told you it's almost like a game because there's so many different ways you can go about this. Sure, yeah. You can't do anything else because x and y aren't the same. Now, the way I would have done it is actually different. I would have started with the same problem. But I'm just lazy. I would have gone ahead and shared that 2 first. So that I would have had x squared squared, y to the -4th squared. Does it matter that my order would have been different? I will get the same answer. Watch. I get x to the 4th times y to the what? -8. Okay. I can't have a negative up top of my final answer. So take it to the bottom. So it gives me, let me change colors again, x to the 4th over y to the 8th. Same answer both ways. Now I'll tell you, for me personally, even though negatives aren't allowed, I usually wait until the very end to deal with them. That's my personality. But it doesn't mean it's wrong to do it first. If you like to go ahead and clean that up first, that's okay too. I personally play with the fractions as little as possible, so I'll wait until the end. But whatever floats your boat, it doesn't matter. Those ways work. Let's look at number 50 though. That's really one that we need to see some practice on. So number 50 on the same page. We have y to the -7 all over y to the -8. Let me talk through the process of how we do this. Actually, you know what? Leave room on your paper. I'm coming right back to that one. Don't let me forget I just wrote, okay? Because I want to make a better example. I feel like I'm rushing to that one. Sorry, trying to be creative here. Okay, that's an x squared right there. I just made this one up. I want you to see it before we do 50. Let me change it. It was 4x, sorry. You guys just love me, don't you? Okay. Okay, that's a little better. All right. So we have lots of pieces, right? First, you have your base 10 stuff, your normal numbers, the 4 and the 2. Take care of that. 4 divided by 2, what do you get? Then what you ask yourself is you say, okay, well, let's see. I have matching bases, right? Stuff with x's. You know, I'm not even going to write the 2 yet. Let's just remember the 2 because I don't want it to look confusing. When I'm looking at the x's, you can write the 2 yourself. It doesn't matter. When I'm looking at the x's, which one's bigger, the 21 power or the 3 power? Okay, let's kill the small one. Going to kill the small one. Then I'm going to take it across the bar and say that means -3. This is the way I deal with my exponents. When I'm combining things, I say, oh yeah, my divide means subtract. Kill the small one, take it away from the big one. This is different than how a lot of professors would have taught it. But it's just the way that I think is consistently easier. So let's see, that gives me 4 divided by 2, we said that was a 2. X, and what is 21 minus 3? 15. That's just a lot harder than it was, huh? I deal with the negative last thing when I'm doing problems myself. So when I look at this, the first thing that I notice is I have same bases on top and bottom. I have x to the negative 5 and x squared. Which one is smaller? Which one should I kill? Negative 5? When I kill it, I actually get minus and negative 5 on the bottom, right? Because you subtract it when you go across the border, when you kill the small one. Minus and negative is the same thing as plus. So on the bottom of the fraction, what do I have? X to the what? Okay, we'll put a 1 up there to hold the space. Cool. So a lot of times it'll actually fix itself for us. That's good to know. Now let's look at number 50. Now I think we're a little bit more prepared for 50. Y to the negative 7, y to the negative 8. Which one is smaller? So I'm going to cancel it. Minus negative 8 on the other side, right? And notice I only can do it because I have y. The bases had to match, guys, or I wouldn't have been able to kill the small one. Okay, let's see, that's the same as plus. So what do I have on top? Y to the what power? Negative 7 and positive 8. What's 8 minus 7? 1? Okay, 1 first. Let's see. Let's look at 68. I'm kind of mixing these up some because I want you to see that really you just have to know the main 3 rules we've learned. 4 rules, I guess. When you're multiplying, you add the powers. When you're dividing, you subtract. When you have the outside thing, you share it, right? And numbers touching numbers, multiply. I might write that for you in a minute if you want me to. That's a 9 in there. Just so you guys know it's kind of messy. You can do whatever you want. You can share that 3 to every single piece if that's what floats your boat. I told you guys when I deal with the onion, I like to start on the inside and work my way out. That's what makes me comfortable. I mean, I deal with negative exponents last, but as far as working in layers, I start on the inside. I'm going to start in there. You guys help me out with that. Negative 12 and 9. What is negative 12 divided by 9? Does it reduce or anything? Okay, sounds good. It's hard. If I get in the middle of the screen for some reason, it starts not working. Okay, so we took care of that. Check. Now for the A's. Which one's smaller, the 2 or the 5? Let's kill it. Subtract it from the bigger one. 5 minus 2, I'm getting an A to the what? Does it make a difference if I write that on top or bottom? Yeah, it does. Notice the A to the 5th was on the bottom. I wrote what I got on the bottom. If it's negative in the end, then I'll move it to the top. I'll move it at the end to clean it up more. But when I'm subtracting, I'm careful with where it's at. B to the 3rd and B to the 9th. Which one's smaller? 3 is smaller than 9. Okay, sounds good. Minus 3. So b to the, what's 9 minus 3? Nice. That was the inside. How are we doing? This is a doozy. This is a hard problem. You guys following? Remember, there's different ways to see. If you saw it a different way, who cares? Just get the right answer. Let's keep going though. We're not done. What else can we do? We've already simplified our numbers. We've put our A's and B's together the best we could. We still have an exponent though. That's 3. Why are we going to get that 3? Everything. You mean the negative 4? Yep. The 3. The A cubed and the B to the 6. Every single piece gets a cube. Now remember, guys, we have divide and multiply only. There's no adding and subtracting in this, like between the A's and B's. You know what I'm saying? That's different, completely different. In this, what we have, negative 4 cubed over 3 cubed, A cubed cubed, B to the 6 cubed. What is a negative 4 cubed?
Negative 6 cubed.
3 cubed?
27.
Do we have a to the what? 3 times 3 is? 6 times 3 is? No, it's not. Oh, you said 18?
Yeah.
Oh, you said 8. I was like, okay, Alex. We can actually, that's 64 and 27. Let's take it further. What do we get? Can we take that a little smaller? Use your calculator, because I really don't know. It looks like you can't. I guess I could cheat and look in the book. You're right, you can't. Nice. This was kind of a big one. This is one where you had multiple steps put together. I could give you one a little harder. Oh, look at that. It's cool. Are you sure it's cool?
Yeah.
Okay, I'm still doing it. Okay. How about, bless you. Here's a challenge problem. Let's do 78, then I'll get more fun. This is just kind of, I want you to use your brain though, so let's look at 78. I mean, I know this is the most boring thing ever. This actually, do you guys see why I call it, why I say it's like a puzzle? Just give me the pleasure of saying, yes, you think it is also like a puzzle. Thank you. Because you can definitely, I mean, you know. Okay, whatever. I'm bad at puzzles too, but I like this for some reason. I'll tell you what I do though. I guarantee when I was a student, I probably took way too long doing these. But who cares? Just don't forget the rules. There's like 4 of them. Go whichever way. The good thing is there's no missing pieces. Just keep going until you can't stop. Okay. Now then. So we have coefficient 0. That negative, is that going to affect anything? No. We don't care. We might care if it were in the exponent, people. But that's just a number. That's the negative 4/3, isn't it? This means nothing to us, except that there's a negative 1 in front of our problem. Look, let's write it. Negative 1. Okay, we've handled it. Can it reduce or anything? No. Ignore it now. Now then, after those x's, this is the tricky part. 5n and 2n, which one's bigger? Which power is bigger? The 5n, so let's cancel the smaller one. We'll kill the 2n. If we're following the pattern, I'm going to subtract what from 5n? Oh, tricky. They wanted us to show them that we knew the pattern. It's not normal you'd have letters up there on top. They want us to use the pattern. So x stays in the bottom. 5n minus 2n, what do I get? Okay, done. Yes, it looks horrific, but again, the author just says, hey, show me you know the pattern. Show me no matter what's up there in the exponent, that if it's smaller, you kill it and take it out off the bigger one. That's what you're showing. Oh, that's true. Yeah, you could just write negative x to the 3n.